Tantor Audio, a division of Recorded Books, presents The Contact Paradox, Challenging Our Assumptions in the Search for Extraterrestrial Intelligence, by Keith Cooper, narrated by Matthew Waterson. Publisher's note: in this audio edition, you will hear references to figures and graphs present in the print and e-book formats of the book. Forward. The modern SETI project, the search for extraterrestrial intelligence, the scientific attempt to detect the alien in the heavens, was initially inspired by an accident of technology. In 1959, not long after the Mark I telescope at Jodrell Bank had been built, two physicist astronomers called Philip Morrison and Giuseppe Cocconi, writing in a paper for Nature, pointed out that the new giant radio telescopes, designed to listen to natural emissions from the stars and planets, happened also to be capable of receiving radio signals from civilizations on the worlds of other stars, and, indeed, of sending such signals. It was an unexpected opportunity, and since, for all we knew then, the sky might have been awash with the signals of alien cultures, it would have seemed remiss not to at least try to eavesdrop. So, the first serious SETI search was made by an American radio astronomer, Frank Drake, in 1960, with negative results. Since 2008, I have served on a committee advising the SETI project about the possible cultural implications of contact with ETI, extraterrestrial intelligence, and have met many of the pioneers, including Frank Drake and Jill Tarter, the model for Ellie Arroway in the novel and movie Contact. It is my personal impression that they expected to detect ETI with their radio telescope searches, if not immediately, then soon, perhaps after a few years. But nearly 6 decades on from Drake's first attempts, as I write, no such unambiguous signal has been detected. Where are they all? In a galaxy of hundreds of billions of stars, shouldn't at least one host a planet with a civilization motivated to make contact, as we seem to be? The mystery deepens when you consider that you don't even need a radio telescope to receive the right kind of signal. Consider optical SETI. I once wrote a story called Eagle Song in my collection Obelisk, about a culture at a nearby star pinging the solar system with a laser bright enough for our sunlight-attuned eyes to see. This is technically feasible. A current project by the Breakthrough Starshot group would send a small probe to the stars by using a powerful laser beam to push a light sail. Such a beam would outshine the brightest star in the sky of a planet of Alpha Centauri, say, if aimed that way. The aliens could have made themselves visible to us by means like this even before Galileo turned his first telescope on Jupiter, but evidently they haven't. Something seems wrong. Maybe we are alone in the universe after all. But as Keith Cooper argues in this timely, sympathetic, but critical survey of the past and future of SETI, our apparently scientific quest for contact with the alien, or at least for evidence of its presence, is actually a deep expression of our humanity. The stars are a mirror, as Cooper eloquently puts it. SETI is perhaps shaped by our deepest impulses, our unconscious prejudices. In which case, it may be no surprise that our minds may not be open enough to apprehend the possibilities. Our search is not yet wide or deep enough, our understanding of the null result so far flawed. So what do we expect, hope and fear of the alien? As a fiction writer, the humanity mirror of most concern to me personally is popular culture, our collective dreaming. In recent years, arguably the most pervasive alien figure in our culture, although it may be a close-run thing with Star Trek's Mr. Spock, has been DC Comics' Superman, a superhero who first emerged in the American comics in 1938. What can this example tell us about our attitude to SETI? It is a valid test case, as Superman was created independently of SETI. Indeed, Superman's story had been established and evolving since long before SETI was imagined. The main elements of Superman's story, the flight of baby Kal-El from the doomed planet Krypton, his landing in a cornfield in Kansas, and discovery by adoptive parents Jonathan and Martha Kent, were established quickly after that 1938 debut. Since then, many talented writers have spent decades brainstorming the implications of having an alien like Superman live with us, for good and ill, and it is generally the ill that drives compelling stories. The elements of the evolving franchise that endure are those that have survived the ruthless Darwinian selection process of success or failure at the bookstands, and latterly in the movies. Something in these particular tropes evidently appeals to large numbers of readers. Superman is not real, but after a decades-long process of storytelling and reader feedback, he may sum up our dream of the alien. So, what can he tell us about that dream? For a start, Superman, though an authentic extraterrestrial alien, is like us. In fact, he's enough like a human in appearance to pass as one, with the cunning disguise of a pair of glasses. The chances are, though, that the alien will not be like us, outside or inside, to the extent that we may not even recognize it as intelligent. Even by 1938, it was a stretch to suppose aliens might be physically indistinguishable from humans. The octopus-like Martians of H.G. Wells's The War of the Worlds, 1897, were quite unlike us physically, although Wells hinted that they might resemble a future evolution of humanity. That alone may represent a considerable barrier to cultural contact. And as for their inner nature, as Cooper points out, we have enough trouble assessing the intelligence of the other living things on Earth, even our closest evolutionary cousins, such as the chimps and dolphins, to be gung-ho about an easy meeting of minds with creatures from another world entirely. Meanwhile, Superman is like us too in his altruism. Superman uses his powers to help us to survive natural disasters and to defend ourselves against the worst manifestations of our own nature. He fights the bad guys, as he has since 1938. It is, of course, possible that unambiguous benefits will accrue from contact with the alien. In this regard, Superman represents the dream of the purely benevolent alien, which the contact optimists like Carl Sagan prefer. Indeed, as Cooper shows, even an alien culture's remotely signaling to us in the classic SETI scenario would necessarily be an act of altruism towards the stranger. Even a simple beacon could incur a significant cost in energy, and much more so a complex signal containing some kind of helpful Encyclopedia Galactica encoded within, as some SETI proponents hope. But need an alien be altruistic to us at all? Even if he is altruistic towards other Kryptonians, and one can imagine entirely selfish races, why should Superman care about us? After all, we are not Superman's kin. We are not even part of his biosphere. Such hypothetical acts of altruism as building SETI beacons become even more puzzling if we imagine worlds beaming out intellectual riches, not just to alien cultures with no hope of reward or even recognition of receipt, but to cultures that may not even exist. It is altruism to the hypothetical. Meanwhile, of course, we fear the non-altruistic invader. The history of contact between human cultures is hardly encouraging, and even an apparently altruistic visitor can be mistrusted. Thus, in the movie Batman vs. Superman, Dawn of Justice, 2016, directed by Zack Snyder, Batman says to his butler Alfred, "Superman has the power to wipe out the entire human race. If we believe there's even a 1% chance that he is our enemy, we have to take it as an absolute certainty, and we have to destroy him." Alfred protests. "He is not our enemy." "Not today," says Batman grimly. Batman, a hero himself who is generally an ally of Superman, is actually being supremely rational, if coldly so. He is using language characteristic of modern analyses of existential threats, threats that pose a danger to the continued existence of the human race itself, threats of extinction. Examples include natural disasters such as massive asteroid strikes, or self-induced calamities such as the destabilization of the vacuum through an unwise high-energy physics experiment. At the minimum, it seems that a consensus is emerging that such threats should be made public and widely debated before any action is taken that could even potentially bring down a terminal disaster on us. And perhaps, so some analysts of the SETI project argue, extraterrestrial intelligence represents one such threat. Currently, there is much debate about METI, Messaging Extraterrestrial Intelligence. Cooper discusses this more in Chapter 7, the idea of sending loud signals to the stars to provoke a response. Maybe we are like innocent baby birds shouting in the jungle while the predators wheel in the sky above us, all unseen, and everybody else is keeping quiet. which is why we don't hear them. Therefore goes this argument, in case the worst is true, we should not message and thereby incur unnecessary risk. Batman would thoroughly approve. In this very welcome new survey, Cooper is telling us that SETI has not failed. In fact, it has barely begun. The fact that we searched first for radio signals was an accident of history. The first SETI-capable receivers we happened to build were the radio telescopes of the 1950s, as Morrison and Cocconi recognized. But infrared lasers, for example, would actually be a much better means of interstellar communication than radio transmitters. And there are other signs of intelligence that we might detect as well as messages, such as technosignatures, evidence of giant technological projects such as the modification of stars. The search is far from over. And what if SETI succeeds? The handling of first contact with the alien is absolutely central to the Superman saga. When he lands on Earth as a baby, an evident blank, Kal-El can be taught our values, for good or ill. In the canonical story, the Kents find him in rural Kansas, treat him well, and encourage him to be kind, loyal, and helpful in turn. He is imprinted with altruism towards humanity, that essential quality that is central to much of Cooper's discussion here, and so he uses his powers for good. But it did not have to be this way. Over the years, the creators have enjoyed playing with other versions of Superman's origin story. Kal-El's fall to Earth was essentially random. What if he had fallen in 1938, not in Kansas, but in Nazi Germany, or Stalin's Soviet Union? In the graphic novel Red Sun by Mark Miller, 2003, Kal-El grew up not with the Kents in Smallville, but on a collective farm in the Ukraine. By the 1950s, the S on his chest replaced by a hammer and sickle, he is ready to wage war to defend the communist ideals he believes are the highest expression of humanity. If SETI succeeds, first contact will probably be a moment of crucial importance, our first and best chance to make a lasting impression on the alien. Perhaps all we can do is to be open, altruistic, and generous to the visitor in the terms of our own culture, just as the Kents were with baby Kal-El, and hope for a similar return. Stephen Baxter. Introduction. Little Green Men. It was early August 1967. Strains of the Beatles' All You Need Is Love filtered up from a record player downstairs as a young PhD student named Jocelyn Bell shivered and closed the dormer window on the cool summer's evening. Before her were rolls of chart paper, the squiggles etched on them little more than gobbledygook to the untrained eye. To Jocelyn, though, the charts spoke her language. She would come up to the attic with them to avoid getting in the way of the other students with whom she shared the house in Cambridge. Besides, John Lennon aside, it was quiet up here. She could concentrate. Little did she realize that she was about to make one of the greatest astronomical discoveries of all time. Yet, for a little while, it looked as if it could possibly be something much, much bigger. Evidence, at last, that we are not alone in the universe. The chart paper was filled with printouts from a telescope that Jocelyn had helped build. It didn't look like a typical telescope. Instead, it was poles and wires strung across nearly 2 hectares, 4.5 acres, of muddy Cambridgeshire fields. However, the Interplanetary Scintillation Array, as the contraption was called, was her meal ticket to a PhD. It was designed to detect radio waves from brilliant quasars, which are the blazing cores of distant galaxies. Pen recorders documented any signals that the telescope detected onto paper. 120 meters, nearly 400 feet, of the stuff every 4 days, which Jocelyn would pick up from the telescope's control room and take home with her to scrutinize. Yet, on this particular evening, amid the familiar squiggles of radio waves from cold hydrogen gas in the Milky Way and the occasional active galaxy, something odd caught her eye. A flickering signal, strange and messy compared to typical radio emission from outer space, like a bit of scruff on the chart. Not knowing what to make of it, she made a note and reported it to her supervisor, Anthony Hewish, the next day. The signal was seriously weird. It didn't move, so it couldn't be an aeroplane or a satellite. It was narrowband, meaning that the signal was extremely focused in wavelength and not blaring indiscriminately across the spectrum, and it pulsed exactly once every 1.3 seconds to an accuracy of a millionth of a second each day. Nothing known in nature was so precise. Jocelyn's colleagues initially joked that perhaps the scruff was from little green men. Those jokes quickly turned alarmingly serious. The late geophysicist Teddy Bullard told Hewish quietly over lunch one day that if the signal were narrowband, then it was probably the result of intelligence. My God, thought Hewish, it just might be. Hewish brought the news that something odd was going on to Sir Martin Ryle, the head of the Mullard Radio Astronomy Observatory at Cambridge University's Cavendish Laboratory. An experienced scientist, yet still a relatively young 49 years old, Ryle was a man who was always very aware of the impact of science on society. He'd seen, for instance, how splitting the atom had led to both new sources of energy and the destruction of Japanese cities. Finding aliens would be another scientific discovery of equally earth-shattering proportions. It wasn't so much the discovery that concerned Ryle, but our reaction to it, followed by the inevitable urge to send a message in reply, and in doing so courting danger by revealing our existence to the universe. Who knew if the extraterrestrials, E.T. for short, although not necessarily as nice as the friendly alien from Steven Spielberg's 1982 movie, would be peaceable or belligerent? Even if they weren't looking to invade like their fictional cousins of science fiction B-movies, they could perhaps deliberately or inadvertently introduce political, religious, or cultural memes or revolutionary technology into our society that could prove disruptive. In a biographical interview in 2008, Hewish gave some insight into the machinations of Ryle's mind. He was only half joking, but he said, "Burn the records and forget about this, because if the news gets out that there is intelligence out there, people will want to launch a signal in that direction to talk to them." Never mind what it could mean for the fate of the human race. The situation was reaching near crisis proportions for Jocelyn Bell. She had a PhD thesis to write, damn it, and this talk of aliens was just getting in the way. On the 21st of December, 1967, she stumbled into a high-level meeting between Hewish, Ryle, and a few others. The whole affair was being kept hush-hush, and, according to Hewish, only half a dozen people knew what was really going on. The reasons for the secrecy were twofold: to keep the media away for as long as possible, and also to prevent other scientific groups from getting the scoop and beating the Cambridge team to the discovery. Plus, nobody wanted to announce the discovery of little green men until they knew for sure what the signal was. Nevertheless, Bell came away from that meeting severely disheartened, knowing that the discovery of extraterrestrial life, momentous as that might be, would scupper any kind of sensible grasp that she had on her studies. That evening, after the meeting, she drove back to the observatory on her little Vespa motor scooter to pick up the latest batch of printouts and run some more observations. It was close to Christmas and terribly cold, the kind of cold that manages to penetrate through to your bones no matter how many layers you put on, and the recorders on the telescope wouldn't function properly in the deep freeze. After the usual cajoling of the equipment in the form of shouting, swearing, and banging it, simply gently breathing on it to warm the electronics proved sufficient, and Bell managed to get the thing working for 5 minutes before it conked out again. Yet, miraculously, it was enough. Perhaps it was fate. She looked at what the telescope had just recorded. There, amid the usual radio emissions of deep space, despite the odds, lay another piece of scruff. A second signal. She was delighted. To Jocelyn, the odds that two alien civilizations would try signaling Earth at the same time in the same fashion from different parts of the sky seemed highly improbable. Whatever the scruffs were, Jocelyn's mind was made up, and soon so was Hewish's. When Bell turned up not only a second source, but later a third and fourth, it was clear that this new phenomenon must be both natural and frequently occurring. We only hadn't seen them before because astronomers had lacked the technology to detect them. Because they pulsed so rapidly, Hewish realized that whatever they were, they had to be small and powerful. Poring through the literature, he swiftly hit upon a mechanism that could explain Jocelyn's scruffs. They were the signals of pulsars, which are the dense spinning remnants of the cores of destroyed stars. Pulsars rotate so fast that a typical revolution can take place in a second, while beams of energy are channeled away by the magnetic forces at their poles. Every time the beams flash in our direction, we see a pulse, like a lighthouse. Footnote: when stars 8 times the mass of the Sun or greater reach the end of their lives, they cause collapse, the shockwave blowing the star apart in a supernova. What is left behind is the compressed remnant of their core, an object so dense that the electrons and protons of hydrogen nuclei have literally been mushed together into neutrons, hence the term neutron star. The force of the supernova gives birth to a spinning neutron star, which we call a pulsar. Some pulsars have even been witnessed spinning hundreds of times every second, and, despite being no bigger than a city, their regular pulses of radiation can be detected across large swaths of the galaxy. Footnote: these whirling dervishes are called millisecond pulsars, and they are spun up to such extraordinary rates by the accumulation of matter streaming onto them from a companion star that is a little too close to the pulsar for comfort. The fastest spinning pulsar, known as PSR B1257+12, rotates on its axis 716 times per second. Indeed, so regular are they that pulsars are the most efficient timekeepers in the entire universe, better even than atomic clocks. The mystery was over. Jocelyn Bell became famous overnight, not as the woman who discovered aliens, but as the young student from Belfast who found one of the most incredible types of astronomical object in the universe. The media promptly descended on Cambridge following the announcement of the discovery in February 1968 and the publication of the academic report in the journal Nature. Today, Jocelyn, now Dame Jocelyn Bell Burnell, is a professor and eminent radio astronomer in her own right, and around 2,000 pulsars have been identified in the Milky Way alone. Meanwhile, Anthony Hewish and Martin Ryle won the Nobel Prize for Physics in 1974 for their work in the field of radio astronomy, including the discovery of pulsars. For Ryle, however, the questions posed by the possibility of contact didn't end there. In 1974, American astronomer Frank Drake composed a message that he beamed to the globular star cluster Messier 13, using the transmitter on the newly refurbished Arecibo radio telescope in Puerto Rico. Ryle was aghast, complaining that Drake had no right to try to communicate with any alien intelligences out there on behalf of Earth, lest he inadvertently cause an interstellar diplomatic incident or reveal our presence to malevolent civilizations. Ryle's warnings fell on deaf ears, but Drake's message proved a one-off, at least until the turn of the millennium. Indeed, the emphasis of the search for extraterrestrial intelligence, SETI, has been on listening for radio signals sent by an alien civilization, evoking the iconic image of actress Jodie Foster in the film Contact, listening on her headphones to radio static detected by the upward-turned dishes of radio telescopes. Drake himself conducted the first search for extraterrestrial radio communication in 1960, and radio searchers have dominated SETI ever since. However, since the turn of the millennium, things have been changing. Scientists are increasingly turning towards other ways to look for intelligent extraterrestrial life, such as watching for powerful beams of laser light or searching for evidence of alien civilizations that have modified their stellar environment in some detectable technological manner. Furthermore, there's a growing impetus from corners of the SETI community to follow in Drake's footsteps and begin transmitting our own messages into space. As our technology to detect and communicate with any alien life that might exist out there grows, SETI is changing, and so too are our ideas about what form alien life might take. The discovery of pulsars was an important test case for SETI. It wasn't the first false alarm, and it won't be the last, but it set the stage to begin asking questions about what communication would mean for humanity. How can we identify a signal of alien origin or their technology? How can we be sure of ET's intentions? How can we respond, and should we even attempt to do so? Who speaks for Earth? What are the dangers of contact? Should we expect there to be life elsewhere in the cosmos? What assumptions are biasing our answers to these questions? It would be presumptuous to suggest that you will find the definitive answers to these questions in the contact paradox. But in a way we can actually do better than that, because in this case the journey is at least as important as the destination. Every one of the questions listed and many more that we will ask in the following chapters, relate just as much to humankind as they do to the search for extraterrestrial life. Maybe there is no one else out there, and we are alone. Or maybe the universe is teeming with life of all varieties. In some ways, it does not matter, because the journey that takes us to one of these answers can teach us a great deal about ourselves. By pointing our radio telescopes to the sky and patiently waiting for E.T. to say hello, we are forcing ourselves to explore humanity's own identity. That, right there, is the crux of the matter, the concept that will play out over the coming sections. The search for extraterrestrial intelligence is at least in part about searching for an echo of ourselves, reflected out there in that starry ocean, a mirror image that we hope will tell us who we are, where we came from, and where we are going. Perhaps the answers that we seek are out there, somewhere, hidden in the nuances of that reflection. As Arthur C. Clarke wrote in his 1951 book, The Exploration of Space, the proper study of mankind is not merely man, but intelligence. Paraphrasing Henry Beston, we are islanded on planet Earth amid a stream of stars. All we can do is gaze out into the ocean of myriad suns and wonder if there is anyone gazing back. Finding the answers to these questions would be the culmination of a centuries-long quest to discover how we come to find ourselves living on a blue planet around a friendly star in the suburbs of a distinctly average galaxy. That quest has taken us through 13.8 billion years of cosmic history since the Big Bang, across eons of galactic evolution and generations of stars, to arrive at an understanding of how our planet came to be, and to look at what lies ahead for the universe in the deep future. SETI is the boldest manifestation of this quest. Yet, all too often, SETI concerns itself with just the technical aspects of the search. Vital as these are, they are only one side of the coin. In The Contact Paradox, we're going to flip that coin and explore the other side too. We're going to cross the borders between disciplines and embrace the social sciences. What will follow over the next chapters will suitably blow your mind. It will be quite a ride as you embark on a journey through physics and astronomy, chemistry and biology, evolution and neuroscience, history and anthropology. And perhaps we'll visit some new lands too. What role does altruism play? How do we define intelligence, and does being too narrow in our definition mean that our searchers will end up missing other, different kinds of intelligence? Are Earth-like planets the only possible abodes for life? And if planets like Earth are rare, does that mean there is unlikely to be life elsewhere? Can life colonize the galaxy? And how do civilizations end? Which assumptions inherent in our ideas about extraterrestrial life are leading us down the wrong path? And how does all this play into the questions Martin Ryle first asked about the nature of contact between civilizations and what the consequences could be? The old history of our search for ET has been told ad infinitum. Starting today, with this book, we begin to look to the future. This is not your parents' SETI. Strap in and get ready for a 21st century SETI. Chapter 1. The Altruism Assumption. William Proxmire knew how to make a name for himself. A Democratic senator, he took his seat in Wisconsin in 1957, replacing the disgraced Joseph McCarthy, who had died months earlier. There, Proxmire remained for 32 years, winning re-election 5 times, yet never spending more than a few $100s during each campaign. It was his tight-fisted attitude towards the use of taxpayers' cash that helped define him as a maverick. Each month, from 1975 until 1989, he issued one of his infamous Golden Fleece Awards to a government or federally funded agency that had spent cash on what Proxmire believed to be wasteful projects. Footnote. A full list of William Proxmire's 159 Golden Fleece Awards, which makes for entertaining reading, can be found at wisconsinhistory.org/turningpoints/search.asp?ID=1742. The Bureau of Land Management were early winners, called to task for spending $11,000 on useless paperwork for a piece of equipment that by itself cost only $4,000. The Environment Protection Agency got it in the neck for spending over $1 million on preserving a New York sewer as a historical monument. Even the army couldn't escape Proximar's wrath.
Sample complete. Ready to continue?